Sacramento County, California. The early 1970s. The American dream blossomed in quiet neighborhoods like this one. Families left their windows open on summer nights. Children played freely until street lights flickered on. Door locks were an afterthought. Then everything changed. It began with a series of home invasions. A masked intruder who slipped through open windows and patio doors. At first, it seemed like ordinary burglaries. Small items taken. Nothing that would make national headlines. But investigators soon recognized a pattern. The precision. The preparation. The perpetrator who seemed to know too much about his target's homes, their schedules, their vulnerabilities. He would call victims beforehand, sometimes months in advance, learning voices confirming who lived there. He cut phone lines, removed bullets from guns kept for home protection, placed dishes on the backs of husbands while he assaulted their wives, warning that he would hear if they fell. What followed was a reign of terror that would span more than a decade. 50 known sexual assaults, a trail of murder scenes across 10 counties, and then silence. The attacks stopped as mysteriously as they had begun. For over 40 years, the case haunted investigators. Evidence gathered, DNA preserved, but no matches in any database. Children grew up without mothers. Parents died without seeing justice for their daughters. Detectives retired, passing case files to a new generation. The perpetrator, whoever he was, appeared to have vanished into ordinary life, leaving behind only nightmares and case files gathering dust. But DNA doesn't forget, and in those preserved samples lay a biological signature, waiting for science to catch up. For decades, that evidence whispered secrets no one could hear. Until now, in 2018, a revolutionary investigative technique emerged from an unexpected corner of the internet. Millions of Americans had begun submitting their DNA to trace their ancestors, find lost relatives, discover their heritage. They built family trees, connected with distant cousins, uploaded their genetic code to public databases. One dedicated investigator was watching this trend with growing interest. What if the same tools helping people discover their great-great-grandparents could identify a killer who had eluded capture for nearly half a century? What if the answers to decades-old questions were hiding in plain sight, nestled in the genetic code of everyday people who had never committed crime? The approach was unprecedented. Take DNA from a crime scene, upload it to a genealogy database, find distant relatives who share genetic markers, then build backward and forward through time, constructing elaborate family trees, narrowing down possibilities branch by branch, generation by generation. The result would shock the nation. A retired utility worker, a former police officer, a grandfather living in a quiet neighborhood much like those he had once terrorized. A man who had blended into society so completely that neighbors described him as merely grumpy or odd, but never dangerous. April 24th, 2018. As morning broke, law enforcement surrounded a home in Citrus Heights, California. When they knocked on the door, they came face to face with a 72-year-old man. "I've been waiting for you," he reportedly told them. "I've been all those things." Across California, survivors and victims' families received calls they had stopped expecting decades ago. The wait was over. The perpetrator had a name, a face, and the breakthrough that led to his capture wasn't a witness coming forward or a deathbed confession. It was a revolutionary fusion of cutting-edge science and traditional detective work, a technique that would transform cold case investigations forever, a method that would give voice to evidence that had been silent for generations. This is the story of genetic genealogy, where the past meets the future of criminal investigation, where family connections built by curious citizens seeking their own histories become the unwitting roadmaps to justice, where killers who thought time was their ally discover that DNA never forgets and family always tells. And this breakthrough was just the beginning. Since that first high-profile arrest, the technique has unlocked mysteries that stumped investigators for decades. Jane and John Does have regained their names. Killers who lived decades in freedom have faced justice in their final years. Families have found closure for wounds that never healed. This is the new frontier in justice, where your ancestry search might be the missing piece in a puzzle someone else has tried to solve for a lifetime. Where the family tree you build for curiosity might bring answers to a family that has asked questions for generations. Welcome to the intersection of science, heritage, and justice. Welcome to the world of genetic genealogy. For investigators, this case represented the ultimate challenge. A methodical perpetrator who left minimal evidence, attacked across multiple jurisdictions, and seemed to disappear completely after 1986. The investigation spanned 10 counties. Each jurisdiction had pieces of the puzzle, but for years, they worked in isolation. Different task forces, different evidence systems, different theories. It wasn't until the late 1990s that DNA analysis confirmed what many had suspected. The crimes were connected, committed by a single individual. By 2001, investigators had something precious: the perpetrator's genetic profile extracted from crime scene evidence. They entered it into CODIS, the Combined DNA Index System, a nationwide database containing profiles of convicted offenders. They waited for a match. None came. Year after year, the same result. No hits, no leads. The implication was clear. Either the person responsible had never been arrested for a felony, or they had been arrested before the DNA collection era began. The genetic evidence, the most powerful tool investigators had, led nowhere. But one investigator refused to let the case go. Even after retirement, he kept searching for new approaches. The answer, he believed, was somewhere in that DNA profile. The question was how to make it speak. The breakthrough came from an unexpected place: the booming consumer ancestry testing industry. Millions of Americans were voluntarily submitting their DNA, hoping to discover their heritage, find distant relatives, or learn about genetic health risks. Companies like AncestryDNA and 23andMe were building massive genetic databases, and some users were uploading their results to public sites like GEDmatch. Two worlds were about to collide: recreational family tree building and murder investigation. The bridge between them? A new field called genetic genealogy. To understand the breakthrough, we need to understand the science. Traditional forensic DNA matching requires an exact match. The suspect's DNA must be in the system. It's like trying to find someone using their full name and exact address. Without that precise information already in the database, you hit a dead end. Genetic genealogy works differently. It doesn't need the suspect's DNA in a database. Instead, it looks for relatives, people who share segments of DNA with the unknown person. The more DNA two people share, the closer their relationship. Parents and children share 50%. First cousins share about 5%, and so on through more distant relationships. The lead investigator partnered with a genetic genealogist, an expert in using DNA to build family trees. They created a DNA profile compatible with genealogy databases and uploaded it to GEDmatch, a public database where users could opt in to share their genetic information. The results weren't immediate or direct. No close relatives appeared. Instead, they found distant cousins, people sharing enough DNA to be related but not enough to know how. Some shared only 0.5% of their genetic code with the crime scene sample, equivalent to third or fourth cousins. This is where the real work began. For each DNA match, the genealogist built extensive family trees, tracing ancestors back generations, then working forward again, identifying every descendant. They constructed over 25 family trees containing thousands of individuals, searching for the point where these separate trees might intersect. The process was painstaking. Birth certificates, marriage records, obituaries, census data, social media profiles. Each document helped place another person in the vast genetic map they were creating. The team wasn't looking for someone with a criminal record or suspicious behavior. They were simply following the DNA generation by generation. Gradually, the net tightened. They identified a particular ancestral couple from the 19th century, then traced all male descendants, since the crime scene DNA showed a male perpetrator. Geography narrowed the field further. focusing on men who lived in California during the time of the crimes. Eventually, they had a short list. Men who were in the right age range, lived in the right locations during the right time periods, and whose genetic heritage matched what the genealogy search predicted. Among them was a former police officer now in his 70s. Traditional police work now merged with cutting-edge science. Investigators needed the suspect's DNA to confirm what genetic genealogy had suggested. They began surveillance, watching his movements, waiting for an opportunity to collect a sample without alerting him. The opportunity came when the suspect discarded an item in public. Investigators seized it, rushed it to the lab, and extracted a DNA sample. The comparison would either confirm years of work or send them back to the drawing board. The results were definitive. A perfect match to crime scene evidence collected decades earlier. Science had accomplished what conventional investigation could not, identifying a suspect who had never appeared on law enforcement's radar, despite having once been one of their own. On April 24th, 2018, as dawn broke over suburban Sacramento, law enforcement surrounded a neatly maintained home. They arrested a 72-year-old man, a retiree, a grandfather, and now the prime suspect in one of America's most notorious cold cases. The announcement shocked the nation. A case that had haunted communities for decades had finally been solved. Not through a confession, not through traditional detective work, but through an innovative approach that combined the most modern genetic science with the oldest of human connections, family. For survivors and victims' families, the news brought a complex mixture of emotions. Relief that someone was finally being held accountable. Grief renewed by revisiting decades-old wounds. And amazement that after all this time, DNA had finally spoken. The legal proceedings moved with unexpected speed. Facing overwhelming evidence, the defendant pleaded guilty to 13 counts of murder and 13 counts of kidnapping. In August 2020, at age 74, he was sentenced to life in prison without possibility of parole. In court, survivors and family members finally had their day. They spoke directly to the man who had caused so much suffering. Some had waited more than 40 years for this moment. Their words carried the weight of decades. Lives forever altered. Holidays spent without loved ones. Nights still haunted by fear. The breakthrough ignited a revolution in cold case investigation. Since this first high-profile success, genetic genealogy has helped identify suspects in more than 200 cold cases across America. People who lived decades thinking they had escaped justice have suddenly found themselves facing charges for crimes committed half a lifetime ago. A woman found murdered in a creek bed in 1981. Identified after 37 years. A hitchhiker killed in 1991. Her case solved in 2021. A serial predator who attacked women in 6 states throughout the 1990s. Identified as a long-haul truck driver. Each case represents lives disrupted, communities traumatized, and families who waited decades for answers. But the technique has also raised profound questions about genetic privacy. When you submit your DNA to learn about your ancestors, are you also volunteering your entire family's genetic information to potential law enforcement searches? Should there be limits on how such databases can be used? Who owns your genetic code? In response to these concerns, policies have evolved. GEDmatch now requires users to explicitly opt in to allow their data to be used for law enforcement purposes. Some states have created legislation governing when and how genetic genealogy can be used in criminal cases. The field continues to balance the powerful potential for justice with important privacy considerations. Today, genetic genealogy represents hope for thousands of unsolved cases. Special units dedicated to the technique have formed in law enforcement agencies across the country. Cold case detectives are being trained in its application. Evidence preserved for decades is being re-examined with this new tool in mind. The science continues to advance. DNA extraction techniques can now work with smaller, more degraded samples than ever before. Genetic genealogy algorithms grow more sophisticated, and as more people add their DNA to databases, the network of potential connections expands. Perhaps the most profound impact has been giving names back to the unidentified dead. People who were buried under markers reading only Jane Doe or John Doe are regaining their identities, sometimes decades after their deaths. Families who never knew what happened to missing loved ones are finally getting answers. For some families, the answers come almost too late. Parents in their 80s and 90s learning what happened to children who disappeared when they were teenagers. Siblings reunited with the remains of brothers or sisters after a lifetime of uncertainty. The closure is bittersweet. The answer they feared confirmed, but the torment of not knowing finally ended. We stand at a remarkable moment in the history of criminal justice, a time when the very essence of who we are, our genetic code, can connect us not only to our ancestors and descendants, but to the cause of truth. When the family trees we build out of curiosity can become maps leading to answers long sought by others. Every cold case represents a wound in the fabric of a community, a question unanswered, a person responsible who walked free, a family waiting for justice. Genetic genealogy offers hope that many of these wounds can finally begin to heal. That question's decades old can still find answers. That time is no longer the ally of those who would escape accountability for their actions. In the end, this science does something profound. It reminds us that we are all connected, that the branches of our family trees extend in directions we never imagined, and that sometimes those connections can reach across time itself, giving voice to those who can no longer speak, bringing light to shadows that have lingered far too long. This is genetic genealogy, where the past and future meet, where science transforms the silent testimony of DNA into the powerful voice of justice, where families seeking their histories help other families find their answers. The new frontier of crime solving is here, and it runs in our very blood. Behind every unsolved mystery is a story that matters. Subscribe and help keep their stories alive.